Okay, good morning, welcome back. This is lesson number 7. Today we're going to cover something called additional properties of lines. We'll just talk very briefly about the quest. I've got some statistics over here on the board. The median score on this quest was 82.5, which means that half of the students who took this quest scored above 82.5 and half scored below 82.5. So it is the middle if everybody's lined up, all right? High grade was a 99 on this quest. In terms of preparing for future quests, all right, so first of all, I don't drop any of the quests, so this one will count for better or worse for each of you, but I will say that this is not the only grade that's going to go into your final grade at the end of the semester. There are 5 quests, just like the one that we took. I do not drop the lowest. No, this is recorded for posterity. I do not drop the lowest. But there are 5 quests altogether. There are 2 tests altogether, and there is 1 final exam. So we were talking 8 in-class things, just like the one you took the other day, and they all get smushed together. And so at the moment, this guy right here, this quest grade, has a very big weight in your grade, which for some of you is good news, and for some of you is not so good news. But I'm saying it's going to get spread around, and this one will diminish in importance as we take these other things. In terms of preparing for the future things, there are lots of resources. I think I kind of listed this on the board the other day, but I'm just mentioning them again. You have each other. A lot of people find that they work really well in study groups, and they just decide they're going to make regular times to meet with each other and work on math stuff. There is me. There is the Math Studio. Again, speaking of a regular schedule, some people just build it into their schedule that every Monday, Wednesday, Friday, right after class, they're going to be in the studio, or every Monday, Wednesday, Friday at noon, they're going to be in the studio. And it's just like an hour built into their schedule, just like any other class you might go to. There is peer tutoring. We had a little presentation about that the other day. There's all the videos that I'm putting up on YouTube. There's resources up on Moodle. And then the practice problems packet, I know that some people have looked through that quite a bit and done a bunch of those problems, and I think that's great. But if you don't do anything in the practice problems packet, I think you're missing an opportunity. So I've highlighted that as a separate resource. Okay, so we are starting here on page 53, way up here at the top. Here's our summary. In this lesson, we explore properties of horizontal, vertical, parallel, and perpendicular lines. 4 facts, 4 things that we're going to talk about. We'll go through them pretty quickly. Just a quick repeated note that I mentioned the other day. We are skipping sections 2.1 and 2.3. They're not part of our curriculum. However, in those sections, the concept of a function is introduced. And while we will not be discussing what a function is, you will see the word function in your reading and in your homework. And so I just need to make sure that anytime you see the word function, you know you should just replace it with the word equation. And if you see any of these funny symbols, f parentheses x, g parentheses x, h parentheses x, which you will see in your homework, you just change them all to the letter y, okay? So just this note is here for you. Keep that in mind as you do your homework. Oh, is it required for the? Yeah. And so it's looking for you to put f parentheses x notation. Okay, thanks for pointing that out. I didn't realize that some of the answers required f parentheses x notation. Okay. Okay, thank you guys. Great. Okay, here we go. Consider these points, 7, 2, -4, 2, and 0, 2. First step is to plot all 3 points. Do that now, please. And once we've got all 3 points plotted, if we draw that line, what word would you use to describe that particular line? It's horizontal. And so that's the answer to part B. The line connecting those 3 points is horizontal. Then it says write an equation for the line that passes through these points. Okay, I know we talked about y equals mx plus b the other day, and we'll use that a bunch this semester, but we're going to ignore y equals mx plus b for this. What is common to the coordinates of these 3 points? What's the same? They have the same y, yes? And how much is y at all 3 points? 2. And in fact, that is the defining characteristic of this horizontal line At every point on this horizontal line, y is equal to 2. X could be anything, but y is definitely 2, and in fact, that's the equation of that line. And I'm not thinking about mx plus b. I'm just thinking about what do all those points have in common. The y is definitely 2. Let's go ahead and calculate the slope of this line. We're here in D now. So remember to find the slope given 2 points. We've got a formula. Let's just use these first 2 points. Upstairs, does it go the change in x or the change in y? Change in y upstairs. So then I'll do the first 2 minus the second 2 upstairs. And then downstairs, what do we put? Yeah, so I'll do 7 minus -4. You can do the other order. 2 minus 2 is 0. 7 minus -4 hardly matters because of that 0. Because how much is 0 divided by 11? 0, and that's why it doesn't matter what's on the bottom. It's just going to be 0. So we'll have our conclusions in a moment, but we just discovered 2 special properties of horizontal lines. Number 1, the equation of every horizontal line is of the form y equals some number. Every horizontal line has an equation y equals some number, which is different. Doesn't look like y equals mx plus b. And the slope of every horizontal line is going to be 0. This isn't just particular to this orange horizontal line. Every horizontal line has a slope of 0. Okay, horizontal lines are in the past. Moving on to number 2. We've got 3 new points. We're going to play the same game as before, so go ahead and plot those 3 points. And if you imagine the line connecting those 3 points, what word describes it? Vertical. And now we're looking for the equation of the line that goes through these 3 points. Looking at the coordinates, what do they have in common? X equals 4 for all 3 of those points. And in fact, for any point on this vertical line, x is equal to 4. That's the equation of that vertical line. X equals 4. Okay, and now we want the slope. So we do the same thing as before. M equals, again, I'll just arbitrarily pick the first 2 points. Upstairs, change in y. So how about we do 2 minus 5? Downstairs, what minus what? 4 minus 4, that's interesting. Upstairs is -3. Downstairs is 0. What is -3 over 0? It is undefined. Some people are tempted to say that that is equal to 0. It isn't. It is undefined. You've been taught from a young age that you are not allowed to divide by 0. So what is the slope of this vertical line? It is undefined. Undefined is the slope. Some people will try to say that it has no slope. I think that's a bad answer. Honestly, I do. I don't think that's a full credit answer. Because the word no in English, like if I say I have no oranges, how many oranges do I have? 0. So when you say you have no something, you are talking a specific number, 0. So to say that this has no slope, to me, indicates that it has 0 slope. And that's not right. This has undefined slope, okay? All right, big conclusions. The equation for a horizontal line, that was the first one we did, is always y equals a number. And the slope of every horizontal line is 0. The equation for a vertical line always has the form x equals a number, like this guy, and the slope of every vertical line is undefined. So there are essentially 4 important things to know about horizontal and vertical lines, and they are all in those 4 sentences down there, all right? Just in terms of keeping the keeping things straight, like I don't want you to guess. I don't want you to take a quest or a homework problem or something and just guess what the slope is, because half the time you'll get it wrong if you just always guess 0 or undefined, right? If you have a line that's going uphill, is that slope negative or positive? That's positive slope. This is something we've seen, right? And if you have a line going downhill, it is negative. Now there's one line that's in between all the uphill lines and all the downhill lines. What word describes that line that's in between? Is horizontal. Yes, that's the one that you pass through going from the uphill ones to the downhill ones. And what's the one number we pass through going from the positive numbers to the negative numbers? Is 0. And the slope of a horizontal line is 0. And so that's how I remember, no positive, I know negative, I got to pass through 0 in between. Okay? All right, next page. Here's the thought process for finding equations of horizontal and vertical lines. So we're not going to read this whole thing, but let's just look at the problem, which is this beginning part. We're going to find the line that has undefined slope and passes through the point 5, -7. Very common homework type question. Undefined slope and passes through 5, -7. So as soon as I see this undefined slope, I know something. I know it's either horizontal or vertical. So if you don't remember which it is, just go back and look at the conclusions at the bottom of the previous page. Undefined slope, horizontal line or vertical line? It's vertical. So this equation is really saying find the vertical line. As soon as I see that, I know they're talking about vertical, right? So we've made our first translation. And then again, looking at those conclusions, every vertical line either has the form x equals a number or y equals a number. Which one is it? Vertical line is x equals. So we've made our next translation. X equals some number is the answer to this problem. The last thing we need to do is figure out what the number is. Well, at the point 5, -7, how much is the x? It's 5, right? At that point, the x is 5. So at every point on this vertical line, the x had better be 5. And that's the answer to this problem. We just grab it from here. That -7 is completely irrelevant. We just need to train our brains to ignore it. So this is the answer to the problem. So x equals 5 is the answer to this problem. X equals 5 is the equation of the line that is undefined slope and goes through the point 5, -7. Okay? So it's not a long process, but you just got to go piece by piece and use the 4 facts at the bottom of that page. Okay, go ahead and try number 5 right now. Find the equation of the line that has m equals 0 and passes through the point 3, 2. Here are the translations we do. M equals 0 describes what kind of special line? Horizontal. Horizontal lines always have what form for the equation? Y equals some number. What is y equal to at this point? 2. That's the answer. And the thought process is pretty much always like that. Okay, so we've said everything we're going to say about horizontal and vertical lines. The last 2 topics for today we'll go through relatively quickly, and they are parallel lines and perpendicular lines. So number 6 says the 3 lines graphed at right appear to be parallel, 1, 2, 3 diagonal lines. Looking at their equations, what do you notice they have in common? Same slope. You see that 2 in front of the x all 3 times, yeah? And in fact, that's always the case. If you have lines that are parallel, then their slopes are going to be exactly equal to each other. And you can also say the sentence going the other direction. If you have lines with the same slope, they are parallel. Works both ways. So that's what it says here in number 2. 2 lines are parallel, number 7, I mean. 2 lines are parallel if their slopes are equal. That is m1 equals m2, m indicating the slope of each of the lines. All right, so that is an important fact. Maybe put a star next to it. That's one of our big conclusions for the day. And then down here, number 8 refers to this last graph on the page. It says 2 perpendicular lines are graphed. Perpendicular means intersecting at what? I heard it. Somebody say it a little louder. Yeah, intersecting at 90-degree angles, yeah? We need lines to be right angles, forming right angles with each other. That's what perpendicular is. And so these lines over here are perpendicular, and And it says find the slopes of the two lines and then find a relationship between the two slopes. All right, so let's split the work up here a little bit. Let's say that the three tables closest to the door, you guys are going to find the slope of that rising line. Other three tables, you're going to find the slope of the decreasing line, the downhill one. In order to find the slope, you need 2 points. You need to be very wise as you select your 2 points. You want to try to grab points that are on your diagonal line, but also on that background grid. Ask one of your neighbors if you're not quite sure how to find some points. Okay, so any of my line 1 people, what's the slope of that rising line? 5? Any of my M2 people, what's the slope of the other one? -1/5. That's it right there. Okay, so here's our big conclusion. These two numbers have a relationship. What's the relationship between those two numbers? What's that? Yeah, the 5 is the same in both. What's the fancy word for when one number is the flip of the other? Reciprocal. Do you buy these are reciprocals of each other? 5 becomes 1/5. So you need to see it throw over 1 right there. So those are reciprocals. What's the other thing that's different? Is one's positive and one's negative. And I think that makes a lot of sense. If you have two lines that are perpendicular, do you buy that unless you're in the extreme case where it's a horizontal and a vertical, which have funny slopes, if you have two perpendicular lines, one of them is going to go uphill and the other one is going to go downhill, no matter how you make these guys, right? So one of the slopes had better be positive and the other one had better be negative. So our relationship here is in number 9. So slopes of perpendicular lines, the slope of one line is the opposite reciprocal of the slope of the other line. Opposite and reciprocal, 2 words, 2 things. Opposite meaning opposite signs, reciprocal meaning flip. So you're going to have lots of sort of algebraic gymnastics to do in the activity today. There's not a lot that you need to know about parallel and perpendicular lines. Parallel, same slope, perpendicular, opposite reciprocal slope, but you will have to do a lot of detective work to try to get at the heart of, oh, okay, but what's the slope of this line? Because Ian isn't being super nice and just telling it to me straight out. I have to do work to get the slope. Then I have to use the, one of these 2 facts here and proceed using mx plus b. Okay, raise the flag if I can help.